Dr. JC here. Welcome to Lesson 4, Tech and Society. This will be the last lesson that we have for the course, and this lecture itself is going to be a little bit abbreviated, largely because of the nature of this lecture. Because this lecture is really ultra modern, and as you'll see as you move through the PowerPoint lecture slides themselves, they happen to be hyper specialized as it relates to your different individual degree specializations and fields. Therefore, in many ways, I'm going to defer to you and the discussions in the class as much as I am going to try to lecture here. Put another way, as it relates to the emerging technologies and aspects in your own degree fields, you're going to be knowing more about that than I will. So I'm going to be in some ways leaning on you all to learn from you in the discussions in the weeks ahead as well. Before we get into a brief discussion about computers, the internet, this ongoing digital revolution, or evolution as I like to refer to it instead, I think we have to pause for a minute and talk about Gutenberg's movable type and the impact the printing press had on society in Renaissance Europe, in the 1400s. We talked at the outset about the impact of Chinese woodblock printing, that the Chinese were actually responsible for early forms of disseminating information on a larger scale through the use of woodblock printing. Well, Gutenberg's going to use various forms of metals, and I'll leave it to you to think about the advantages of using metal type pieces rather than wood per se. But what I wanted to talk about briefly here and get you to think about is what impact did Gutenberg's movable type have on society? We're talking about a society before this that if they wanted information duplicated or replicated, it was usually done in a monastery by some monk or monks, line by line, handwritten. Very laborious, very time-consuming. With Gutenberg's movable type, however, volumes can be printed expeditiously, and most importantly, in one's own language, in one's own vernacular. So I'd like you to think about for a minute the impact of people to be able to have access to information in their own language much more readily, much more expeditiously. What impact might that have on innovation, ideas, and perhaps calling into question existing truth claims or the order of things? Do people really need to listen to kings and or church leaders anymore? So Gutenberg's movable type will have a huge impact on society, and we'll talk about briefly here in a few minutes whether or not the internet in our own age is, we can liken that to Gutenberg's movable type as well. So what's this whole business about the history of computing? Well, rather than get into the hardcore history of it, I think we could at least introduce this gentleman here, Konrad Zuse. And in some ways, Zuse is still remembered as the individual who came up with the world's first programmable computer. Konrad Zuse is going to be doing most of his work on these programmable computers in Germany in the early 1940s. For those of you that are familiar with world history, you might recognize, hi, this is smack dab in the middle of World War II. That Zuse is actually going to be in Germany during Hitler's reign, during the reign and rule of the Nazi Party. This is not meant to imply that Konrad Zuse was part of the Nazi apparatus himself. He just happened to be a very advanced entrepreneur, innovator of his age, and therefore the Germans would rightly make use of him as best they could. Interestingly, after the war ends in 1945, Konrad Zuse will begin to shop some of his ideas abroad. And in 1946, he will begin to sell some of his patents to corporations such as International Business Machines, or IBM. Therefore, Zuse's work is going to stretch across the pond, from Europe to the Americas now. And we'll talk about IBM and Tom Watson Sr. here in a little bit. At the same time that Zusi is doing his work on programmable computers in Germany, in the United States, individual firms, academic institutions, governmental agencies, especially the military or Department of War, was known as the Department of War at the time. It's the Department of Defense today in the United States. These individuals would and entities would come together to start to discuss ways to make this efficiency movement that's sweeping across the United States, make that applicable to war in the battlefield as well. How do you take Taylorism, or these concepts of efficiency and continuous improvement, and apply them to the battlefield? In the summer of 1943, the military worked with the University of Pennsylvania's Moore School on what was known at the time as Project PX. Today we know that as ENIAC, or ENIAC. It's an acronym for Electronic Numerical Integrator and Computer. And for all intents and purposes, what this ENIAC program, or Project PX, was all about was a way for the United States to use its artillery and make its artillery fire much more effective. Now, they're not just looking to limit the amount of collateral damage to civilian buildings or the cost of civilian lives, but the sheer cost of artillery shells themselves. That the government was concerned about, hi, we're not just going to go out there and fire lead down range for the sake of firing lead down range. We want to go ahead and be as efficient, focused, and connected with each of these rounds as possible. We want them to do the most kinetic damage possible and get the most bang, pardon the pun, for the buck. In 1946, about the same time Zusi begins to sell some of his patents to companies like IBM, back here in the United States, the work done in the ENIAC program is advanced as well. Now, this is going to be a partnership between, again, academic institutions, private equity firms, U.S. government, looking for ways to advance this idea of digital computing. So different discussions, different think tanks begin to emerge. One such example of that, as depicted here on this slide, are these Moore School lectures. It's a series of lectures that brought together leading engineers, leading minds of the day, especially those from the Western world, Britain, Canada, the United States, to talk about where we might be able to go with computing. Before we get into personal computing, we'll talk a little bit about Microsoft and Apple here in a minute. I have to start with IBM. I've mentioned IBM a couple times, but I want to focus specifically on the gentleman shown on the slide here, Tom Watson Sr. And the reason I want to focus more on Tom Watson Sr. even more so than IBM per se, is because in many ways he personifies, at least to me, this coming together of continuous improvement, the Taylorism, as it begins to bridge into Ed Deming's PDSA cycle. As we begin to see this transition from, hi, the one smart guy sits at the top of the company and everybody else follows their orders, to the more modern sort of approach, which is to empower employees and basically flip that business pyramid upside down so that the frontline workers are the individuals that actually drive change. Because in many ways, Tom Watson is the guy that started that. Many of us today have heard of IBM's ThinkPads, right? Where does that motto, think, come from? Well, it comes from the guy on the screen right here, Tom Watson Sr. And one of his corporate mantras, one of the ways he wanted to build the IBM brand, was to get everybody in IBM as an organization to think. Take time to think. If you've got an idea, I don't care how crazy it is, share it. Let's talk about it. Let's see if we can put this vision to practice. He wanted all of his employees to be visionaries. And in this regard, Tom Watson is asking, imploring really, his employees to share what it is they know. And it's this corporate culture, this idea of allowing your employees to think and share their ideas, that really catapulted IBM to the forefront. As depicted on the slide here, from the early 1980s all the way to the early 2000s, 20 straight years, IBM held the most number of awarded patents. You say, well, what's a patent? A patent is a legal document that states an idea is a company's or an individual's own intellectual property. No one can copy that. So for 20 years, IBM is out patenting everyone else out there. What's another way to say that? They're out innovating everybody. It should be little wonder why they were so successful. Now, IBM didn't always get it exactly right. They tended to focus more specifically on business contracts, governmental contracts, and didn't really take seriously this idea of personal computing. Folks like Bill Gates and Paul Allen, we could in some ways call them equal parts independent and responsive innovators, yes? They're not creating the computer new, but a new approach to it. Rather than doing it for business or governmental purposes, the individual could use this. And they would share their ideas with IBM, try to get some financial backing. Unfortunately for them, they were laughed out of the corporate boardrooms, largely because they would try to sell this idea of using a mouse, to which corporate folks at IBM would laugh and say, the only person that's interested in having a mouse in the house is Walt Disney. Beat it, you 1970s freaks. So for good or for ill, depending on how one views it, Bill Gates and Paul Allen had to strike out on their own, and strike out on their own they did, and well and fully. And you guys largely know the story as it relates to Microsoft today, becoming a leader in the software world. I did want to make one quick mention, though, before we pivot to Apple briefly, and talk about this giving pledge. The giving pledge that you see in the modern age, this includes the Warren Buffetts of the world, the Zuckerbergs of the world, the Larry Ellisons of Oracle, and others. This is the modern 21st century version of that gospel of wealth that Carnegie started in the early 1900s. The Bill and Melinda Gates Foundation is an example of that. These are wealthy entrepreneurs today that have committed to giving huge sums of money back to the communities. And I want to give a nod to these folks because they don't have to give this coin up, but they do. That leads us into Apple Computer. Again, I'm not going to get into the detailed story here. You guys all know it likely even better than I do. But I want to point out the one guy on this screen you might not know something about, Ronald Gerald Wayne. Ronald Wayne was one of the original 3 founders of Apple Computer. And he himself was responsible for the creation of the first logo of Apple Computer. The original logo depicted here to the left says along the border, Newton, a mind forever voyaging through strange seas of thought, alone. What? Now, whether or not Wayne was dropping little pills that made him see pink and purple polka dot dragons like Jobs was, we'll save that for another discussion altogether. And what the blue blazes he meant by that expression we'll save for another discussion too. But the fact that he used Newton here pulls us back to Europe, the scientific revolution, and the period that preceded that, the Renaissance. We're going back to Gutenberg's movable type. Did these guys see Apple Computer as the way to unleash the new digital revolution, as a new wave of disseminating information en masse like we saw during the Renaissance? I think they did. And to conclude the lecture here, we'll work ourselves into the father of the World Wide Web, Tim Berners-Lee. And I'll leave it for you to decide whether or not this World Wide Web, social media, is a blessing or a curse. Dr. JC out. Lesson 4.